So now that we're more comfortable with manipulating expressions with exponentials and logs, I want to go back and review the concept of an inverse. And also I want to show you how logs and exponentials are inverses. So if you recall the definition of an inverse, if two functions are inverses, we'll call them f and g, then f of g of x has to be equal to x, and it has to work in the other direction as well. G of f of x also has to be equal to x. It has to work for both directions with composition in order for them to be considered inverses. So what I want to do is show you that if I have an exponential function, b to the x, and I have a log function, base b, that these are inverses. So I'm going to first show you that f of g of x is equal to x, and then I'm going to show you the other direction, g of f of x is also equal to x. So for the first direction, I'm going to take g of x and plug it into f. So I'm going to take log function, log base b of x, and plug it into the function b to the x. So I'll have b to the power of log base b to the x. And this is equivalent to x because if you think back to our properties, when this base and this base is the same, what it's equivalent to is whatever this value is. So this direction works. B to the power of log base b of x is equal to x. Okay, now let's do it in the other direction where I take f of x, which is my exponential function, and plug it into my log function. So I would have log base b, and then in place of x, I would put b to the x. According to our properties, this is also equivalent to x, because when this base and this base is the same, the answer is going to be whatever this is. So this direction works also. So we can say that b to the x and log base b of x are inverses. So if I asked you what is the inverse of log base 5, you could tell me without even thinking about it, the inverse is 5 to the x. These are inverses. Okay, now, given a log function, I want you to be able to find the inverse. So in this example, it says find the inverse if the function is log base 3 of x minus 1 plus 2. So if you recall, in order to find an inverse in equation form, what you would do is you would switch the x's and the y's and then resolve it for y. So I would rewrite this equation as x is equal to log base 3 y minus 1 plus 2. And then I would have to resolve it for this y. Well, now we have a log equation to solve, and we just learned about how to solve log equations so that we can do this with no problem. So the first step in solving a log equation is get all the logs together condensed on one side and everything else on the other. So the first thing I want to do is subtract 2 from both sides. And that way, I get my log condensed by itself. Once I have it condensed and by itself and everything else is on the other side, then we put it in exponential form. So my base is 3, my exponent is x minus 2, and I set it equal to y minus 1. My last step is to finish solving for y. So I would just add 1 to both sides. So I would take 3 to the x minus 2 and add 1. So my inverse of log base 3, x minus 1 plus 2, would be the exponential function 3 to the power of x minus 2, and then plus 1, which would be a shift up 1. Going in the opposite direction, If I have an exponential function and I ask you to find the inverse, then you're going to end up with a log function. So same as before, if you're looking for the inverse and it's in equation form, you switch the x's and the y's and you resolve it for y. So I'm going to rewrite this equation as x is equal to 5 to the 3y minus 7. So now I have to resolve this for y. Well, when I solve an exponential equation, I want to get the exponential part by itself and then put it in log form. So I'm going to first add 7 to both sides. And now that I have the exponential part by itself, I'm going to now put it in log form. So my base is 5, so I have log base 5, x plus 7, and my exponent is 3y, so I set this equal to 3y. And then to finish solving for y, I divide both sides by 3. So I would have log base 5 of x plus 7 all divided by 3. And this would be my inverse. So when you're finding the inverse of an exponential function, it should come out to be a log function. And when you're trying to find the inverse of a log function, it should be an exponential function.